We learned previously that if we are given a partition f1 through fn of our sample space S, then we can compute the probability of an event E by summing together the probability that E occurs in each member of the partition. Using conditional probability, we also learned an alternative way of computing these probabilities. If we substitute this equation into our total probability expression, then we get the following useful alternative to the law of total probability. As an example, let's look at the seasonal flu. We're told that the flu will infect 40% of the population, and that we have a test for the flu. However, this test only returns a positive result 99% of the time if you actually have the flu, and 5% of the time it will say that you have the flu even if you don't have it. This is called a false positive. So if we pick someone totally at random from the population, what's the probability that if they're given the flu test, it comes out positive? Let's define two events, F for those people who have the flu, and NF for those people who don't have the flu. This is a partition of our populace. Each person either has the flu or they don't, and no person can both have the flu and not have it as well. Now let's define T to be the event that a person tests positive, and that's the probability that we're trying to find. So by using the law of total probability, we can decompose this in terms of F and NF. The problem statement gives us each of these numbers. For the first part of the equation, the probability that a person has the flu is 40%, and the probability that they test positive if they have the flu is 99%. In a similar fashion, we can get the no flu numbers as well. Putting this all together, the probability that a random person tests positive for the flu works out to be about 42.3%. Okay, let's make it a bit tougher. Let's suppose that I give you 3 bags labeled A, B, and C. Each bag consists of some allocation of black and white balls according to the following scheme. Now, we roll a fair 6-sided dice, and we will use the result of that dice to choose a bag. If we choose 1, 2, or 3, we'll choose from bag A. On a 4 or 5, we'll choose from B, and on a 6, we'll choose C. If we pick one ball from the selected bag, what's the probability that that ball is black? Just to be tidy, let's define the event A to be that we choose bag A, and similarly for bags B and C. The event K will correspond to us choosing a black ball from the bag. Now A, B, and C partitions our space. We must choose one bag, but we can only choose one bag. So by the law of total probability, the probability of K can be computed over this partition as so. Let's sort these probabilities out by drawing a picture. Here's bag A with 3 black balls and 1 white ball, and we choose this bag on a roll of 1, 2, or 3. I'll draw a similar picture for bag B, and one also for bag C. Now looking at bag A, the probability that we choose a black ball from this bag is 3 out of 4, and as we choose this bag on a roll of 1, 2, or 3, the probability of picking bag A works out to be a half. We can apply the same reasoning to the other 2 bags as well. Taking these numbers and plugging them into our formula thus gives us our answer, which works out to be about 65.3%.